Mr. Brian. This is my video for the Skywatching Lab. These are all cosmological events that have happened or will happen, first starting with the eclipse in 2017. As you can see, the spot that the moon creates on the Earth from blocking out the sun slowly moves across the middle of the United States and into the dark side of the Earth. Not too interesting, on to the more interesting ones. This is the Voyager 1 spacecraft flyby of Jupiter in 1979. One thing to keep an eye on would be the speed of the Voyager, which will be on the left side of your screen in the middle, in kilometers per second. You'll see that as Voyager 1 approaches Jupiter, it will start to get faster, and this is a gravity slingshot, essentially. Next up, we have the triple eclipse of Jupiter in 2015. This was when Io, Ganymede, and Callisto, all within a few minutes of each other, created a eclipse spot on Jupiter, and I believe it was in that order. I just find this so cool to watch. So as you can see, Io came in there first. This would be Ganymede, traveling a little bit faster than Io, you can see by the dots in the eclipse. And then as soon as that one leaves the screen and goes on to the dark side, we should see, yep, there it is, Callisto coming up right over the big red spot. Here we have the eventual simulation of the Milky Way and Andromeda Galaxy collision, which will happen in approximately 4 billion years. What you will see is that many stars and solar systems will be ejected out of both galaxies far off into space, but likely none will collide considering the distance between them is so large. You will also see the black holes. They just merged, creating one black hole. And I will just let the simulation play out. At no point in the simulation does the galaxy actually reform into the spiral that we know it to be. That is so far in the future that I actually get into Google years before that happens, and I am not willing to wait that long. So I'm currently going by about 1,000,000 years a second, is what you're seeing right now. That is the speed of this simulation. So here we have the eventual supernova of our sun, which will happen when our sun becomes a white dwarf. And what I also do is I show you the view from Earth, or what Earth would look like when this happens. One thing to keep an eye on is the temperature, and as well the picture in the top left of the screen. Um, as soon as I start the simulation, the sun will now go supernova. And as you can see, Earth is obliterated and proceeds to get so hot that the simulation cannot handle it anymore and eventually deletes Earth right there. So yeah, what I believe happened is it reached the 32-bit integer and the simulation just couldn't handle it anymore, and rolled over and ended up deleting the planet. Um, Supernovas are really, really beautiful things to look at, especially in the simulation. So, yep, enjoy. This is the Parker Solar Probe, closest approach to the sun. It launched on August 12th, 2018, and took many loops in its 7-year mission period. And this is the closest one, making it the closest man-made object to the sun ever. One thing to keep an eye on is the temperature. It almost gets to about it gets over 1,000 degrees Celsius, which is miraculous that the hardware inside did not just fail. The final thing I decided to end on was our galactic center. Sagittarius A is the black hole in the center of our Milky Way galaxy, and I wanted to show a few of the bodies and objects that orbit around and how they orbit around. Um, so this is a year a second what you're currently seeing, and I just think it is absolutely insane how these different planets and celestial bodies are just absolutely zipping around this black hole. Um, Basically, it's a constant slingshot, but they can never reach escape velocity by doing that. They'll always just get closer and closer until eventually they reach the event horizon and disappear forever.